Good afternoon. Thank you for the introduction. I'm very glad to have opportunity to speak on this conference for the first time here. So thank you for having me here. Before I start my presentation, I just want to briefly introduce you to my previous work, because this paper is actually a continuation of my research that I conducted for my doctoral thesis, which I defended last year. And in that research, I developed methodologies for automated actually assessment of BIM models in relation to green building certification systems. In that research, I used BIM software, Revit, and its integrated tool for visual programming called the Dynamo. So with this research, I wanted to explore how AI can be integrated in such methodologies in order to facilitate standard certification procedures, as well as to enhance the standard building design processes. As we all are aware of, architecture, engineering, construction, and operations sector is currently facing major changes driven by sustainability requirements on one side and rapid digital transformation on the other side. So, to support sustainable construction, several green building certification systems have been developed, including the American LEED, British BREEAM, DGNB German one. There are a lot of different certification systems globally, but this is just my selection. So these systems define environmental performance requirements and guide project teams throughout the design as well as certification process. So if we are talking about buildings, we heard also at this conference, among all building types, healthcare facilities are especially challenging because they operate continuously and require strict technical standards related to ventilation, indoor air quality, infection control, energy performance, etc. So as a result, sustainability certification in this kind of projects is often complex, time-consuming, and dependent on manual interpretation of regulation and documentation. So BIM technologies can provide a strong digital foundation for integrating sustainability criteria directly into our design workflows. At the same time, recent developments in AI, including machine learning or NLP, for example, create new opportunities for automating compliance checking, predicting certification outcomes, or supporting better design decisions. So, however, despite this progress, both in AI and in BIM research, their combined application for healthcare-oriented sustainability certification workflows is still limited and fragmented. So, healthcare buildings, we heard about that I think yesterday. These kind of buildings are considered one of the most complex building types within the BIM environment. And why is that? Hospitals operate continuously and include highly specialized systems such as controlled ventilation, medical equipment, infection prevention zones, which significantly increase energy demand and operational complexity. So in addition to energy consumption, healthcare facilities also generate large quantities of medical waste and hazardous waste, so making sustainability management even more challenging. So, because of this, sustainability certification in healthcare buildings goes far beyond standard certification procedures and environmental assessment. So it requires actually both sustainability criteria and medical technical standards. So as a result, certification processes are highly complex and require continuous coordination between architects, engineers, sustainability consultants, facility management teams, etc. So this research actually focuses on possible applications of AI within BIM-based sustainability certification workflows. The main idea is that BIM provides structured project data, while AI we can use, and AI enables actually smarter interpretation, prediction, and optimization processes. So this research identifies three main application areas of AI. Rule interpretation, which means that AI can automatically read and organize all certification requirements and regulations. The second one is predictive assessment. That means that AI actually can predict certification results and detect potential problem areas in the design phase, which is very important for us. And the third one is design optimization. AI can generate and optimize BIM decisions, BIM design solutions based on sustainability and also healthcare requirements. So this research combines BIM data, structured BIM data, certification requirements, and the third one is AI-based analytical methods or tools within one integrated workflow. This framework consists of 5 interrelated layers: BIM data layer, certification knowledge layer, AI interpretation engine, which is central layer of this workflow, compliance validation module, and the last one is the decision support interface. I will just tell a few words about them. The BIM data layer represents actually the digital foundation of the proposed framework. It contains all structured building information, including geometry, spatial, material, system level data, including ventilation rates, medical equipment loads, etc. Unlike traditional certification workflows that rely heavily on documents and manual checking, BIM enables direct extraction of project data that we need from the digital model itself. So we have it already prepared. We just need to use that information. So for example, ventilation rates, filtration levels, daylight performance, information about material data needs to be included in a BIM model as a measurable and machine-readable parameters. So this layer, BIM data layer, acts as a main data source for all later analytical and AI-supported processes in this framework. The certification knowledge layer transforms sustainability certification requirements and healthcare regulations into structured digital rules. What that means, certification systems such as LEED and BREEAM define their requirements through textual descriptions, performance limits, or conditional criteria. In healthcare project, we have these requirements must also be aligned with technical standards, especially those related to ventilation, indoor air quality, infection control. So the main role of this layer is to convert these written requirements into machine-readable logic that can be analyzed automatically in the later stages. The AI interpretation engine represents the central intelligent component of the proposed framework. This layer may include several types of AI technologies. For example, NLP models can automatically extract and structure compliance requirements from certification manuals and technical regulations. For example, machine learning algorithms can analyze historical data and to predict certification outcomes or identify potential risk, high-risk credits during the early design stages. Optimization algorithms can also evaluate multiple design options and recommend solutions that can improve sustainability performance. The fourth layer is compliance validation module. It connects big data layer certification rules and AI analytical processes in one operational workflow. Its main role is to automatically evaluate whether the project satisfies certification requirements or not. The model can generate outputs such as pass or fail results, warning notification, risk levels, predicted performance scores, for example. And every time the model is modified, the system can automatically perform a new assessment. And that is very helpful because it helps to identify potential compliance problems early before later project stages where design changes become much more expensive or difficult to implement. So the final layer of the framework focuses on presenting analytical results in a clear and understandable way for project teams. Its purpose is to transform that complex technical outputs into actionable insights for architects, for engineers, for sustainability consultants. So this allows interdisciplinary teams to interpret these certification results. By providing a real-time feedback during the design building design process, the framework supports continuous optimization of design solutions. So the main conclusion of this research is that combining AI and BIM technologies can significantly improve green building certification processes, especially in complex projects such as these healthcare facilities. So today, the most certification procedures are still time-consuming, fragmented, and largely manual. Because of that, designers often receive feedback too late in the process when changes are difficult or expensive or expensive to implement, or we cannot implement it at all. So these problems can be solved earlier in the design process. The proposed framework aims to change this approach by enabling continuous and automated compliance checking directly within the model environment. So in this way, project teams can receive real-time feedback during design, development, and make better informed decisions earlier in the process. Although this framework is currently conceptual, the research demonstrates strong potential for applying AI-supported BIM workflows. So future work should definitely focus on real-world implementation and further development of intelligent and interoperable certification workflows. Thank you for your attention. I look forward to your questions.
Very much. Make sure you connect on the Slido using the first QR code.
Hello. Let me see my question because I might mess it up. Right. Should we integrate healthcare certifications with ongoing monitoring after we have built the building in order to verify the initial computational models, and in a way to recertify the initial certification. You know, if we have succeeded, what we have in the initial plans to the real life of the building. What do you think?
Yes, we have certification procedures during design, design of buildings, but there are also manuals that cover that part of our usage of buildings or operation. Yes, we can use that. We can monitor our buildings and use that for certification, but I think that this also is part of this future work. Thank you.
Great. Thank you very much.